Now, how do we even find this? F to the power of 1965, 0.5, or even questions like F to the power of 2001, x. Now, let's check it out in this example question over here. Now, we are given a function, fx is 2x minus 1 over 2x minus 2, and we need to find the f inverse in similar form. So let's start off by writing let y equals to 2x minus 1 over 2x minus 2, the usual way that you always do. Now recall that we need to make x the subject in order to get the inverse. Now let's do a quick cross multiplication here to give us y, 2x minus 2 equals to 2x minus 1. Subsequently, we will have 2xy minus 2y equals to 2x minus 1. And by factorizing x, we will then have x 2y minus 2 equals to 2y minus 1. And x is simply 2y minus 1 over 2y minus 2. Now, don't just stop here. We will need to define the f inverse in similar form as required by the question. Now, to get the domain of the f inverse, it is equivalent to finding the range of the original function of f. Now, if we were to sketch a quick graph of f, the range is given by negative infinity to 1. Now, therefore, the f inverse in similar form is 2x minus 1 over 2x minus 2, and the domain is x less than 1. Now, the next requirement from the question is to find the composite function fx, denoted by f squared as shown. And the key word is hence. So meaning we could make use of the answer in the earlier part to derive our answer very quickly. Now observe that the original function fx is exactly the same as the f inverse of x. We could first write it this way. Fx is equals to f inverse x. Now use the power of association to help you. So whenever you come across the f inverse kind of questions, always associate it with this rule, f inverse x is equals to f inverse fx is equals to x. By making use of this rule, we can introduce the function f on both sides of the equation right here. So doing so will give us a composite function fx on the left hand side and f inverse fx on the right hand side. Now if you can see further, the left hand side is f square x, which is exactly what we want. And the right hand side is simply equivalent to x, based on the rule over here that we see. Therefore, f to the power of 2x is simply equals to x. Now, by doing so, you need not substitute fx into fx, and this wonderfully improves your speed significantly. Alright, so now let's approach the final part of the question to evaluate f to the power of 1965, 0.5. Definitely, we are not going to substitute the function f more than 1,000 times into the original because it will take years to get the answer. Now, the question advises us to state the answer. So f to the power of 1965, 0.5 is simply 0. Now let me explain how this is derived. Please note that this is not part of the working since the question requires us to simply state the answer. Now we have f to the power of 2x is equals to x from the previous part of the question. This means that f to the power of 3x is equals to the composite function f to the power of 2x, and this will be equals to fx because f to the power of 2x is simply x. So as we go on, f to the power of 4x is equals to f to the power of 2, f to the power of 2x, and it simply equals to f to the power of 2x. Alright, and f to the power of 2x is equals to x. Now you notice over here that f1965x is an odd number. So this is equivalent to f to the power of 1964x, and this will be equals to fx. Or you could also simply look at it this way, f to the power of 2, which is an even power, is equals to x, f to the power of 3, an odd power, is equals to fx. Now f to the power of 1965, This is an odd number, therefore it will give us fx. Therefore, f to the power of 1965, 0.5, is simply substituting 0.5 in the original function of f, which gives us a value of 0. Now I do hope you have learned something from this example. Please subscribe to this channel to see more valuable contents. If you have any questions or requests for a topic to be covered, do leave them in the comments box below. And thank you so much for watching.